In this unit, I will discuss a new technique to solve quadratic equations. This is a standard quadratic equation. Two roots alpha and beta of this equation are given by this expression minus b plus minus square root of b square minus 4ac all divided by 2a. Suppose we want to solve the quadratic equation x square plus 28x plus 27 is equal to 0. So first we identify a, b and c. A in this equation is 1. B in this equation is 28 and c is 27. These values are substituted appropriately into this equation and the result is alpha beta is equal to this expression, which finally gives us the roots alpha and beta as minus 27 and minus 1. Now let's develop a new technique as follows. The sum of roots alpha and beta, as is well known, is equal to minus b over a, and alpha and beta product is equal to c by a. Let us assume two numbers p and q such that p is equal to minus a into alpha and q is equal to minus a into beta. Then p plus q becomes minus a into alpha plus beta, and this becomes minus a into minus b over a equal to b. So p plus q becomes b. P into q is equal to minus a into alpha, which is this quantity p, and minus a into beta, which is this quantity q. So their product becomes a square into alpha into beta is equal to a square into c by a is equal to a into c. We will now use p and q to find the solution of the quadratic equation. We may write p plus q as given to us 28, and we break up this into 20 and 8 are 22 and 6 are 24 and 4 are 27 and 1. These are perfectly arbitrary values we have assumed for p and q. However, their sum must equal the given sum of p and q, 28. This sum is the same, this sum is the same. All sums are really the same as 28. However, what remains to check is their product. Product of 20 and 8 is 160. Product of 22 and 6 is 132. Product of 24 and 4 is 96. So we discard this combination of p and q, or this combination of p and q and this combination of p and q. However, this combination of assumed p and assumed q gives us the product 27, which is the desired product. So this value of p and this value of q, these are the acceptable values of p and q, or they are true values of p and q. Now using these true values of p and q, we can find alpha as minus p by a equal to minus 27 and beta as minus q by a equal to minus 1. Now the most important part. This process can be repeated with the given sum p plus q and the given product p into q by assuming a starting value of p and q, each as p plus q by 2. And we introduce an increment or decrement as t, so that we may write an assumed value of p as p plus q divided by 2 plus t, and assumed value of q as p plus q divided by 2 minus t. So this is assumed t. This is assumed p. This is assumed q. Their product becomes this. This product must match the given product p into q. Thus p plus q divided by 2 square minus t square is equal to p into q. Therefore, we get t square as p plus q by 2 square minus p into q. Therefore, t becomes equal to this. This is increment, decrement, a very important quantity, and when it is added to p plus q by 2 plus t, this gives us the correct value of p, and when it is subtracted from p plus q by 2, it gives us the correct value for q. Now let's solve this quadratic equation which we previously solved. Here is the solution. P plus q is equal to 28 and p into q is equal to 1 into 27 is equal to 27. So we find the value of t by the expression that we derived earlier, and the value of t turns out to be 13. Thus the value of p becomes p plus q by 2 plus t, which is 14 plus 13 is equal to 27. Q similarly becomes 1. Alpha is equal to minus p by a equal to minus 27 by 1 is equal to minus 27, and beta is equal to minus q by a equal to minus 1 by 1 is equal to minus 1. Now let's solve another equation. 36x squared minus 103x minus 120 is equal to 0. Here we see that p plus q is minus 103 and p into q is 36 into minus 120 equal to minus 4320. We first calculate the value of t, which is given by this expression, and when we substitute values we get t as 83.5. Thus p is equal to p plus q by 2 plus t, which becomes minus 51.5 minus 83.5 is equal to minus 135. Similarly, q becomes this value 32. Alpha is equal to minus p by a equal to minus of minus 135 by 36, which is equal to 15 by 4. Similarly, beta is minus q by a equal to minus 32 by 36 equal to minus 8 over 9. Thank you.